So always look at the answer, and this will give us a clue. We have cosh to the n minus 1. So I'm going to start by splitting the integral into cosh x, cosh to the n minus 1x with respect to x. We're going to let u equal cosh to the power n minus 1 of x. So whenever we differentiate that, we bring the power down. We multiply by the differential of cosh x, which is sinh, and we take 1 away from the power. dv dx equals cosh. Whenever we integrate that, we get sinh. We now need to take these sections and put them into the integral by parts formula. So we have that in equals uv minus the integral of v du dx so we have our original. I'm going to bring the n minus 1 outside the brackets. We have sinh squared sinh squared is cosh squared minus 1. So we have that in equals cosh squared times cosh to the n minus 2 gives us cosh. So that's going to be in. And we also have minus n to the minus 1, the integral of minus 1. So if we have a minus 1 and a minus here, that's going to give us a plus. The integral of cosh to the power n minus 2. I know my next line that is going to be in minus 2. So we now have that in equals and now we need to bring everything together. So on the left hand side we're going to have n minus 1 in plus in, which is going to give us n in. And on the right we're going to have our sinh cosh to the power n minus 1 plus n minus 1 in minus 2. So in equals our sinh cosh plus n minus 1 in minus 2 as asked for in the question. To find this area, we're going to integrate from 0 to 1 cosh cubed x with respect to x. So we are being asked to find I3. So if I use our formula from before, that is the sinh of x cosh squared x. Remember to put in our limits, 0 to 1. Sorry, 3I3 equals plus n minus 1 in minus 2. So 3I3 is going to equal our square brackets plus 2 times the integral of cosh from 0 to 1. The integral of cosh is sinh, so that gives us inside square brackets sinh cosh squared x plus 2 sinh x, all to be evaluated from 0 to 1. Now, because of the answer to the question, I now know I'm going to have to use the exponential form of the hyperbolics. So 3I3 equals, and such is e to the 1 minus 1 over e, 1/2. Cosh squares will be 1/4 e to the 1 plus 1 over e to the 1, all squared, plus 2 times 1/2 e to the 1 minus 1 over e. We then need to substitute in the 0. So we are going to be taking away 1/2 e to the 0 minus 1 over e to the 0, and that's just 0, so I'm going to ignore the rest of that. Plus 2 over 2 e to the 0 minus 1 over e to the 0, and again that's going to be 0. So 3i3 equals just this first section, which we're going to have to evaluate. 1/2 times 1/4 is 1/8, and we have e minus 1 over e. Next bracket squared will be e squared plus 2 times the product of the terms, which will be 1 plus 1 over e squared, plus e minus 1 over e. So now we need to do some manipulation and expanding brackets. 3i3 equals 1/8 e cubed plus 2e plus 1 over e, and then I'm going to multiply by the minus 1 over e. So that is minus e minus 2 over e minus 1 over e cubed. In my second bracket, I'm going to make it a plus 1/8, 8e minus 8 over e. So 3i3 equals 1/8. I only have one e cubed term, but I have 2e minus e, which is e plus 8e, so I'm going to have plus 9e. I have 1 over e minus 2 over e, so that is minus 1 minus 8 over e, so I have minus 9 over e. And then we have a minus 1 over e cubed. If I divide by 3, I'm going to get 1 over 24, and I know from the answer that I need an e cubed as my denominator. Means my first term becomes e to the 6, my second 9e to the 4, my third minus 9e squared, and my last one is a minus 1. So I3 equals e to the 6 plus 9e to the 4 minus 9e squared minus 1 all over 24e cubed.